Good morning, my friends. I'm Clover, and this is Genuinely Approachable Sudoku. And today we're solving a puzzle by Philip Newman. This was originally posted on Valentine's Day, February 14th, 2025, and it is called Green Heart Emoji. And in classic Philip style, we have a heart-shaped German Whisper Sudoku. I think Philip has been doing the heart theme on and around Valentine's Day for the past couple of years now. I'm not sure that we've done German Whispers before. We've definitely done Killer at the very least if you go back and check out previous years' Valentine's Day puzzles from Philip. But this one is a German Whisper Sudoku. So we have standard Sudoku rules in each row, column, and outlined 3x3 region. Every digit has to appear exactly once. And then there's also this heart-shaped German Whispers line in the grid. So along a German Whispers line, adjacent digits always have to have a difference of 5 or more. So we're going to start here. There's only one digit in a Sudoku grid that has a difference of at least 5 away from 6, and that is 1. And then placing the ones there lets us place a 1 in this region because 1 can't go next to 2 on the line, so 1 can only go there. So now we know something about the what I've heard called high-lowity of the German Whispers line. We know that the digits that I have highlighted here, because along a German Whispers line, digits have to alternate back and forth between high and low. We know that these guys have to be high, because to have a difference of at least 5, only high digits can be next to only low digits. So these guys have to be low. They have to be 1, 2, 3, or 4. And we can make some eliminations based on that. So there's already a 6 in this region, there's already a 1 here, and there's already a 2 in this region. 3 or 4 cannot be next to 6 or 7, so that's going to have to be 8 or 9. 2 can't be next to 6, so we're going to eliminate 6 from this cell. 6 also can't be here, and neither can 9 because those already appear in the column. This cannot be a 4. We can't have 8 or 9 here, so that's a 6-7 pair, and the only number that both 6 and 7 can be adjacent to is going to be 1. That eliminates 1 from this cell. Now, this can't be a 1 because we have a 1 in the row. This can't be a 1 because we have a 1 in the row, and it also can't be a 4. And because this can't be a 1, 6 can only be next to 1, so we can eliminate 6 from those cells. 7 can't go next to 3, so we're going to eliminate 7 from right there. Oh yeah, this has to be next to either 6 or 7, so it must be a 2, which will be next to a 7, and then we're going to make that digit a 6. Now, this can't be a 6 or 7 because those cells can't be next to a 3, and this can't be a 2 or a 3 because we have those in the region already, / in the row, and it can't be a 4 because 4 can only go next to 9. That's the only digit that's far enough away from 4 in order to fit next to it on a German Whispers line. So this is going to be a 1. So that's our first pass of cleanup on the German Whispers line. Let's see what else we can do here. So this can't be a 7 because it's got to be next to the 3 or 4. And this is something kind of fun. We have an 8-9 pair in row 4 now. So we know 8 and 9 can't be in these cells. They can't be in these cells because these cells are already occupied. So where do 8 and 9 go in region 5? They have to go in these cells somewhere. We don't know exactly where, but that is enough to tell us that this must be a 7, which is going to make this a 2. We can do a little more Sudoku right here. We have 6s here and here. They see these cells, therefore 6 in region 6 has to go right there. And the remaining digits on this row are going to be 1, 2, 3, and 7. This guy can't be a 1, this can't be a 7, this also can't be a 1, so the only place for 1 in the row is going to be right there. And now 7 can't be in any of these cells, so 7 in region 5 must be there, making this either a 2 or a 3. So these guys are now 2, 3, 8, or 9, and that is not going to be a 9. We need to place a 2 somewhere in this region. It's got to go in one of these 2 cells. Not sure beyond that where that's going to go. Over here, we need to place a 1 in region 6. It'll go right there. And here we need some combination of 3, 8, and 9. So, where are we going from here? This is the part where the puzzle starts to get a little bit tricky. So here we need 3, 7, 8, 9. And we can't quite reduce that yet. This can't be a 7 because we have a 7 in the column. This column is looking a little bit restricted, so we can only use in this column 3, 4, 7, and 9. We can't place a 3 in either of these cells. Oh, and I did just notice when I was looking at that 3 that that gives me a 4 right here, which is going to make these two digits both 9s. That's not going to be a 9. That's going to be an 8, making this a 3, 9 pair. That eliminates 3 from these cells, giving me a 7, 8 pair. And now I need to place a 4 in the region. It'll go right there. This will be either 2 or 3. So now this cell makes this an 8. And we still need to place 8 and 9 here. This can't be a 4 because we have a 4 in the row at this point. So the remaining digits in this row are going to be 2, 5, and 6. And because we have a 2 and a 5 here, this is going to be a naked single 6. This will be a 2. Because we have a 5 below it, this is a 5, and now this is a 3. The only digits that can be next to 3 are going to be 8 and 9. We can't put a 7 next to a 3. That's not a difference of 5. This is now going to be a 7. We can make some kind of minor eliminations here. We can eliminate 3 from these cells. That places a 3 there and a 2 there. This couldn't be an 8 or a 9, so this is going to be a 2 with an 8 and a 9 next to it. And now to finish off this column, we need 2, 3, and 5. 2 can't go in either of these cells by Sudoku, so it's going to have to go right here. To finish this region, we need a 3, a 5, a 4, and an 8. These cells can't be 3 or 5, thanks to the 3 and 5 in column 5, so that'll be a 4, 8 pair. And these guys are going to be 3 and 5. These will be 3, 4, and 5 to finish the column, making these two cells a 6, 7 pair. Let's take a look at this region. We need to place a 2 somewhere. 2 can't go in these cells, so it'll go right here. And we need 4, 9, and 6, if I'm not mistaken. That can't be a 9, because we have a 9 there. In this region, we need 3, 5, 7, and 8. These can't be 3 or 7 because those already appear in the column, so that's a 5, 8 pair. This is going to be a 3, 7 pair, and that makes this a 6. We can eliminate 6 here and place a 6 in this region now. The 8 here gives us a 5 and an 8, and then the 5 is going to resolve this region, leaving us with just a 3, 7 pair and a 4, 9 pair in row 1. In this column, we now need a 2 and a 6 to finish off, and we have those right away. We get a 3 and a 5 here by Sudoku. In this column, we're going to need a 1, a 3, a 6, and a 9. Neither of these can be 1 by Sudoku. That's going to be our 1, hidden 1 in the column. This can't be a 6 or a 9, so that's a 3. That resolves the 3, 9 pair that we placed a little while ago. The 8 here resolves the 4, 8. Did not spot that earlier, but now we've got that. In this row, I still need a 4 and a 9. And the 9 in this column resolves that. I've got a 4 here, and a 9 here, and a 4 here. Now I need a 5 and a 7 to finish off this region. Over here, I'm going to need a 3 and a 9 to finish the row. And a 7 and a 3, and an 8 and a 7, and finally our last two digits by classic Sudoku are going to be 5 and 8. And that is how you solve Philip Newman's green heart emoji for Valentine's Day. Hope you guys enjoyed that one. If you want to solve it yourself, the link to do so is in the description below this video. And I'll see you again in 3 days.